Hello everyone, welcome to this topic, classes and objects in Kotlin. We were talking about the OOP in Kotlin. So in this topic, we will go through four subtopics. The first one is to introduce the classes and objects in Kotlin. Then the defining, like how to define a class and how to create an object from the class. Whenever we talk about the definition of a class, constructors, and initialization of the class should be learned, right? Because this is an important part in OOP. So in Kotlin, we have the constructors and initializer blocks. The final part is about the properties and fields. This subtopic talks about the members, especially for the properties, the data members inside a class. And in Kotlin, we enforce the accessors and mutators. So there are some additional concepts to learn. Okay, so for classes and objects in Kotlin, basically they are the same, right? In OOP from as the other OOP languages. Class could be considered as the data type of an object. So class is compile time entity and object is a runtime entity. So since we have the data type and the value, okay, object represents the value. So Kotlin offers a refreshing and concise approach to classes and objects, making object-oriented programming more efficient. That's in the syntax level. So later we will see the approach that Kotlin language chooses. By the end of this section, you will understand how to define class, create object, and utilize constructors in Kotlin. The language simplifies OOP with cleaner syntax and powerful features that reduce the boilerplate code. If you are familiar with Java programming, you will you will see that there are a lot of the so-called boilerplate code to write. Even you use an IDE, it can automatically generate some boilerplate code for you. Uh, they still make your code clutter, right? Sometimes it makes your code clutter. So in Kotlin, they try to okay make them invisible, right, from the syntax level. Okay, so how to define a class? Kotlin's class syntax is more concise and efficient than Java's, making it easier to define. To declare a Java in Kotlin, we use the class keyword, okay, and followed by the class name. For the body of the class, right, we use curly bracket to enclose the definition of the properties and methods. So here is an example. In Kotlin, a simple class, okay, we call it person, okay, with name and age can be defined like this. In this example, you will see that we use a parenthesis right after the class name. So that means this is called the primary constructor, a primary constructor. So all the parameters listed in the primary constructor, okay, would be related, right? Would be related to the internal property. So we may consider that in a person, a class, there is a property called name and a property called age, and name is immutable, age is mutable. We now explicitly specify the name and age. The tool would generate the two fields or the two properties for you. Right? So by this way, by this line of class definition, actually the tool generate the class definition like called person with two internal members, a name and age. Uh, Furthermore, for each generated uh, property, accessors and mutators are also generated. For VAL, since it's read-only, so only the accessor is generated. For VAR, it's read-write, so both accessor and mutator are generated. Okay? So it is important to know that Kotlin classes can have properties and functions, but sometimes you don't see the exact uh, specification because some of the properties can be and functions are automatically generated. So the benefits of the Kotlin class definition is quite similar to the general object-oriented concept. First, encapsulation. We encapsulate the related data and function as a group and make them internal. That means make them private and only publish some public interface to the others. So this is a modularization unit. So it increases the reusability and also increases the modularity. Okay, so uh, here properties are declared within the constructor, reducing the boilerplate code. Okay, as we mentioned that in the primary, in the primary constructor, okay, all the parameters are related to the properties. If the dedicated property is not specified, they will be generated by the tool. Kotlin automatically generates fields and basic getters. For setters, they are generated for the var properties. Then, how to create an object? It's pretty simple. Okay? We don't need to use the new operator. Simply provide the class name and the necessary initialization values according to the constructor. Okay? So from our previous example, we need a name and age. Okay? So simplicity and intuitiveness. The simplicity in object creation not only makes your code cleaner, but also more intuitive for developers coming from different programming background. It is important to note that every time you call the constructor, a new instance is created. Okay? Then Kotlin provides concise syntax for initializing object properties and setting default values. This reduces boilerplate code and makes object creation more efficient and readable. For this feature, we will see some more detailed example later. Okay, so for the primary constructor, it's part of the class header, defines the essential, okay, we call it them essential properties, and specify we can also specify the visibility modifier. For visibility, it's another feature that we will talk about at the end of the topic. Okay? So for essential properties, okay, VAL, the immutable essential property, a getter is generated, or var, essential property, getter and setter are generated. Okay, then sometimes we would like to initialize our code, okay? Initialize our object with that is not dedicated to the constructor. It's related to the class loading. So Kotlin provides initializer blocks prefixed with init for complex initialization. It's similar to the concept of the static initializer in Java, but not the same. Okay, they are not the same. So initializer blocks allow additional code to run during object creation. By object creation. So in Java, the static initializer is dedicated for the class loading phase. In the class loading phase, however, in Kotlin, right, uh, the initializer blocks are used, are executed while object creation. So there could be multiple initializer blocks. So our initializer blocks and the properties would be interleaved. They are executed in order. In order. So these blocks offer a flexible way to customize the initialization process of objects. Then, in addition to the primary constructors, there are secondary constructors. So secondary constructors are defined inside the class and can call the primary constructor using the this keyword, this keyword. They provide flexibility for more complex initialization scenarios while keeping the syntax concise and clear. You may consider that we just create a secondary constructor. For example, we just for the person class, suppose we have a secondary constructor and it only takes a name, assuming the default age. Okay, then in the constructor, it calls the primary constructor by passing the provided name and the default age to the primary constructor. So some of the secondary constructors could be chained if we have multiple secondary constructor. Maybe a secondary constructor one would invoke a secondary constructor two, the secondary constructor three. However, at the end of the constructor call, it should be the primary constructor. So it's a chain of constructor invocation. And the final one should be the primary constructor. Then let's talk about the internal members, the properties and fields. In Kotlin, class properties are a first-class language feature. For example, in our person class, name is read-only, age is mutable. They are declared at the top level of the class and can be either mutable or read-only. So Kotlin properties abstract the concept of fields and accessors, eliminating the need for explicit getters and setters in Java. This point describes that a property, right, in Kotlin, a property is not the variable itself. It's the variable, right, the data member, and the accessors. Here the accessors could be getter, right, for VA for var, or getter setter for var data member. Okay, so it's a concept. Right? It's a concept. We call it property. That means there is a memory storage and the associated accessors, okay, for getting the value or setting the value. So whenever we would like to modify the memory storage, right, or when we would like to access the memory storage, no matter it's read or write, we have to, right, or implicitly by encoding, we implicitly use the accessors to access the memory storage. Okay, this is a very important concept in Kotlin. Okay, in Java, we separate the data member and its accessor and mutator or getter setter. Then that means whenever possible, we can directly assign a value to the data member, or we can directly read a value from the data member. In Kotlin, even, right, while writing uh, the code using an assignment, the tool would transform the assignment to use the corresponding getter or setter, right, implicitly. Right? Please note that it implicitly, right, calls the getter or setter, right, according to your syntax. And that implies Kotlin also provides the mechanism for the programmers to specify the constant accessor. Okay? If the generated getter and setter are uh, not work, right, in the way we want. For example, for setters, right, the generated setter is simply pass the value and assign the value to the data member. However, we would like to have a validation phase. That means we check whether the value is within the allowed range. If it is not, we throw an exception or something else. So we can customize the accessor. Okay? So custom accessors can be provided in Kotlin for specific behavior when a property is accessed or modified. And the built-in property support in Kotlin makes classes less verbose, more readable, and reduces the need for writing boilerplate code. Okay. So now, here is an example of the custom accessor. By a rectangle, right, we need the width and height. So here is a property called area. And it's interesting that previously we say that the property, right, is the memory storage and its related or associated accessor functions. However, in this example, area is just a name, just a name. Uh, Actually, there are some other kind of properties. Remember, in the we've talked about the lazy and something else, right? Some of the properties can be cached. So only the first time, when first time we executed, its value will be evaluated and saved in the property. But that's another some other issue. So in this we just have a name, property name called area, and it's an integer. Whenever we would like to read the value, okay, we this is the getter. Okay, so after the type of the property, we can specify the getter and its calculation is this that width times this that height. Okay, so this is a custom accessor example. Then here is another example, and we need to learn something new. Okay, for example, we have a class called grade, okay, and we save the score inside. For the score is var, right? So without this part, we will have a data member called score, and with the accessor and mutator, accessor mutator. However, if we would like to customize or we would like to explicitly specify the getter and setter, here is the example that the property name is called score and it's an integer. It is initialized, right? Initialized by the parameter called score. Right? So these two are not the same. Okay? These two are not the same. The score here is the property, and the score here is the name of the parameter. So the property is initialized by the score. And while initialization, actually we use the setter to set its value. So when set its value, we use the keyword field, the associated field called score, and it is initialized. Sorry, here should be the value. Right? It should be value field equal value. Right? Why we the reason, right, that we need to use the keyword field is that if we use score here, from the viewpoint of the set, set the setter, score refers to the property. So that means we assign the value to score. And then when assigning the value to score, the the setter will be invoked again. And within this, right, again, we encounter score. So we would like to set the value of this score. So this is a recursive, infinite recursion. And eventually, we will encounter the out of memory issue. So that's why we need the field keyword, right, to stop, right, actually to prevent the recursive call. Right. So the field keyword is called the backing field. And why do we need it? Right. Here, it is the explanation. Uh, if we specify counter equal value, then eventually we will have a stack overflow issue. Right? And using actual name counter would make setter recursive. Okay, so this is the reason why we need a field keyword. Okay, and this is the final slide for this topic. Let's talk about the packages. In Java, we have many. We usually put a class definition inside a package. So it's similar to Java. Right? In Kotlin, we use package keyword and import keyword, similar to the Java syntax. If you would like to learn more detail, please refer to the official document. And here is the visibility, public, private, and protected and internal. Right? So without package statement, that means your class will be the top level and it's no name, no package name. And in Kotlin, it supports the alias. So while importing some class as the alias, that means afterwards we can use the alias as the class name. This is a great way for distinguishing the same class name from different packages. Then the third point is Kotlin does not require matching the source file location, a source file location to the package hierarchy. You may compare to Java. In Java, the Java files should be organized in the directory hierarchy that matches the hierarchy, the package names. Okay? So we need to put for example, the Java source file. Uh, Suppose we have package one dot package two dot class. That means the class file should be organized in the subdirectory package one and subdirectory package two. Okay. So in Kotlin, the the tool does not require this. However, according to the building environment and the build tool you use, for example, IntelliJ or Android Studio, they may organize the file locations, okay, for project management. Okay, that's not uh, that's not the specification in Kotlin. Okay, so this is a pretty long topic. Right? We go through the definition of a class and how to create an object, the constructors, the initialization blocks, and finally we talk about the properties and customize how to customize the accessor functions with the field keywords and the packages. Okay.